Hi all, in this video we are going to discuss about digital voltmeter integrating type. A digital voltmeter of the integrating type is an electronic instrument designed to measure voltage with high accuracy and precision. It measures the true average value of the input voltage over a fixed time. It converts the voltage to frequency at first. Then the frequency is measured and it will be proportional to the input voltage. This is the block diagram of digital voltmeter integrating type. Okay, then let's see the dual slope integrating type DVM graph. Compared to RAM type DVM, here we use two slopes of RAM signals. One is positive RAM and the other is negative RAM. In case of RAM technique, we encountered a disadvantage, that is, a large error were introduced due to the superimposition of noise of the input signal. So, to overcome that disadvantage, the dual slope integrating type DVM are used. Here, the construction of DVM integrating type. The construction of an integrating type digital voltmeter involve several key components that work together to accurately measure voltage. Here's an overview of its main components and how they function. First one is input circuit. Voltage divider. A voltage divider circuit is used to scale down the input voltage to a level suitable for measurement. This helps protect the internal components from high voltages. Next one is analog input. This is where the input voltage is received. It may include protection circuits like fuses or diode to prevent damage from over voltage. Second one is sampling circuit, sample and hold, or S or H circuit. This circuit is captures the input voltage at a specific point in time, holding it steady while the measurement is processed. Okay, then third one, integrating circuit, integrator and timing control. First one, integrator. This is a crucial component that integrates the input voltage over a defined time period. It typically uses an operational amplifier or op-amp. It's an integrator configuration where the output voltage is proportional to the time integral of the input voltage. Timing control. A timer or clock generates the time intervals for integration, determining how long the input voltage is sampled and held. Fourth one is analog to digital converter or ADC. After the integration process, the analog output voltage from the integrator is sent to an ADC. The ADC converts this continuous analog signal into a digital representation that can be processed and displayed. Fifth one is microcontroller or processor. The microcontroller processes the digital signal from the ADC. It may perform the additional calculations, apply corrections like temperature compensation, and manage the overall functioning of the voltmeter. Display unit, digital display and control buttons. Digital display. The processed digital signal is sent to a display unit, usually an LCD or LED screen, where the voltage reading is shown in a user-friendly format. Control buttons. Users can interact with the DVM through buttons to select measurement ranges, zeroing or other functions. Power supply. The digital voltmeter requires a stable power supply to operate its various components. This could be from batteries or an external power source, often with voltage regulation to ensure consistent performance. Last one is calibration circuit. Many integrating digital voltmeters include a calibration circuit to adjust for any discrepancies in measurement accuracy, ensuring that the readings are reliable. Let us discuss about the working of integrating type DVM. This voltmeter employs an integration technique which uses a voltage to frequency conversion. The voltage to frequency converter functions as a control system which governs the rate of pulse generation in proportion to the magnitude of the input voltage. A train of pulses are generated and the number of pulses appearing in a definite time interval is counted. The frequency will be a function of the unknown voltage. If a constant input voltage is applied, the integrator produces an output which is at uniform rate and polarity opposite to that of the input. The level detector detects the magnitude of output from the integrator. Basically, it is a comparator which compares the output of integrator with a fixed value, and when these two values are equal, it passes an output to the pulse generator gate. The output of the level detector opens the pulse level gate, permitting pulses from a fixed frequency clock oscillator to pass through. Let's see the block diagram. Here in this type DVM actually help to reduce the noise in the input signal. In this circuit, two inputs are used. First one EI and other is minus ER is being fed one common switch. Then we are using a capacitor through a resistor. The capacitor will start charging and use integrator. We know that an integrator integrates the input voltage. So we feeding a constant input voltage, that is E1, to integrator. The output of integrator will be linearly increasing voltage. Then the output voltage is fed into a comparator. One of the input of comparator is E0 coming from the integrator and the other is ground voltage. The output of the comparator is connected to the one input of the gate. Other input of gate as a pulse coming from an oscillator. The oscillator is always producing pulse. The pulse is passing through a gate. This pulse is fed to a counter, and we know a counter is count the pulses from 0000 to higher numbers. The counter is counted from 0000 to higher values, that the value is 9999 value. And the moment counter will be maximum value, it will be activate a flip-flop, and a flip-flop is connected to a switch drive and which shift the switch from one to another input voltage. In this circuit consists two voltages. First one EI. EI is a voltage that we feed into the system. Other is minus ER. Minus ER is a fixed voltage. EI is varying and minus ER is constant. Then the switch shifted to the input of the integrator from the input voltage EI to minus ER, since the negative voltage is feeding to the integrator. The voltage continuously decreases from thereby feeding negative voltage. Then the gate will be closed. The counter displays some value depending on how many number of pulses pass through the gate. The pulse generator produces an output pulse of fixed amplitude and width. The output pulse is then fed back to the input of the integrator. Then no more pulses from the clock oscillator will pass through the pulse generator. When the output voltage pulse from the pulse generator has passed, it is restored to its original value and starts its rise again. The pulse generator is triggered by a pulse form. The clock generator and the entire cycle is repeated. The frequency of the wave is a function of the voltage being measured. One pulse from the pulse generator is produced for each cycle of the wave. The number of pulses produced in a given period of time interval, and hence the frequency is an indication of the voltage being measured. Let us discuss about the advantages and disadvantages of DVM integrating type. First one, advantages: high accuracy, high noise rejection, and high stable as compared to other type of DVM. Then disadvantages. First one, longer conversion time, more complex and high cost. This is the commonly used DVM brands, Keysight and Flock.